Hi again, welcome back. Let me try to solve the problems now here uh, on uh, cost reduction formulas. Okay, let us look into those problems. Now we do have this integral. If I take okay, so integral of 8, which is cos power 5 dx. Okay, 4x dx. Let us try to evaluate this problem. Okay, now I can write 4x as d. So d 4 dx is equal to dt, or dx is equal to dt by 4. So I'll take 1 by 4. Now this also changes, so it will be 0 to pi by 2, 0 to pi by 2, cos. Now this will be cos power 5 into t, and this is dt. Okay, now that is equal to 1 by 4 into now by reduction formula we have 4 into 2 divided by 5 into 3. Again, this after simplifying it, I get 2 by 15. This will be the solution for this. So what I've done is I've substituted 4x as t, and then afterwards if you are substituting 4x as t, so the t ranges from 0 to pi by 2. That's it. Let us see another problem here. Again, reduction formula for cos. So integral 0 to pi by 4, 0 to pi by 4 cos 2x to the power of 5 by 2 and cos x dx. Okay, now for this, let me put as root 2 sin x as sin theta. Okay, here. So now the theta value ranges from, that is 0 to pi by 2 here. Theta will be ranging from this. Now I'll get square root of 2. The sine is cos x dx, and on the right hand side I'll get this is cos theta d theta. Let us substitute the things which are said. So if you take to the other side, it is 1 by 2. Let us substitute this where what I have mentioned here. Okay. Uh, Now cos 2x, I can write this as 1 minus 2 sine square x. Right? So let us substitute that, which I have said. So that is 1 by root 2. This will be, I mean, if I simplify this, I get this will be with respect to theta. So 1 minus sine square theta, 1 minus sine square theta. and this will be 5 power 2, 5 by 2, and this is cos theta d theta. This is cos square. So 2 gets cancelled, cos power 5 and cos power 1. So it becomes cos power 6 theta d theta. Okay, so this is 1 by root 2, 0 to by 2. So this would be 1 by root 2. So 5 into 3 into 1 divided by 6 into 4 into 2 and multiplied by 5 by 2. So further getting the result here 5 pi by 32 root 2. This will be the solution for this. Let me move on to the next problem. So the method of substitution depends uh, or varies from problem to problem. Okay. Okay. Let us take another problem. This is minus pi by 2 to plus pi by 2. Now you have cos over 7 x dx. Let us try to integrate this. Now this this will be which is ranging from minus pi by 2, 0, and this is pi by 2. So I can use integral part here, which is ranging from minus pi by 2 to 0. Now this is cos over 7 x dx. Okay. Again, I can write this as 0 uh, to pi by 2. Okay. 0 to pi by 2 cos over 7 x dx. Now if I substitute here some t as minus x, t as minus x. So dt will be minus dx. Let us put that here. So I get this is minus pi by 2 to 0 cos 7 minus t, and this is minus dt. And again this will range to plus. Okay, I'm changing this variable, right? So this is for t as pi by 2 and 0 plus. I'll have again 0 to pi by 2. Now this is cos over 7 x dx. So what I've done only for this change only. Now this will be if I change the uh, limits 0 to pi by 2. So this will be cos power 7 into t dt. Okay. Again I get back the same as that. So I can change the variable to x, right? So this is 2 times adopt this. Or the solution for this is to multiply by 6 into 4 into 2 divided by 7 into 5 into 3. Okay, this would result to 32 by 35. That is the solution for this. Okay, let me try to solve another problem. Let us try to integral 0 to a x square, okay, and a square minus x square. Find 3 by 2 dx. Let us integrate this. Now let us substitute x as a sine theta. So dx will be a sine cos. Okay, let us integrate this. So this is 0 to pi by 2, limits. Okay, so which is a square sine square theta, a square sine square theta. So this is multiplied by a square minus a square theta to the power of 3 by 2. And dx is a cos theta into dt. Now if I try to simplify this further, this is a square and this is a cube, so a power 5, and I have a here, so a power 6. Integral 0 to pi by 2. Now this is sine square theta and 1 minus sine square theta, which is cos square. Uh, Now we have 3 by 2, so I can write on the whole, if I try to simplify it, I get cos cube theta here. Okay, if I multiply this, I get cos power 4, and this is theta. Now further, I can write sine square theta as 1 minus cos square theta. Now if I multiply throughout this, so I get this as integral 0 to pi by 2. This is cos power 4 theta d theta minus integral 0 to pi by 2 and cos power 6 theta d theta plus this. Okay, now this is a power 6, okay, multiplied. Now this is even and this is also even. So this would be 3 into 1 divided by 4 into 2. This is pi by 2. And this is 5 into 3 into 1 divided by power 6, right? So it is 6 into 4 into 2 and multiplied by pi by 2. Now, if I try to further simplify this, I get pi a power 6 divided by 32. This is the final result. I hope you understood this one. Let me take one more problem and try to solve that. Now, if I take the integral 0 to infinity x square divided by 1 plus x over 6 and 7 by 2 dx. Let us try to solve this. Now, let us put x power 6, okay, as some tan square theta. Okay, so I get x cube as tan power 1 by 3 theta. Okay, so if I take dx here, so dx would be if I try to put that, so this is 3x square dx. Okay, and that would be 1 by 3 if I take only x, okay, if I take only x term here, so let me only take dx here. Okay, so that would be 1 by 3 times that of tan of 2 by 3 theta. Okay, and tan would be secant square theta and d. The limits will be changed to 0 to by 2 because it's tan. Just put that, so this is tan to the power of 2 by 3. Okay, theta. In the denominator I have 1 plus what I have taken as tan square theta. Now this, the power is 7 by 2. Now this is multiplied by 1 by 3 times, that is tan inverse or 2 by 3 and secant square and d theta. So that's the rest. Now further, this is secant square. Okay. Now this is secant square power 7 by 2, and I have secant square theta. Okay. So if I simplify that, and if I simplify all those, now this and this gets cancelled. Okay. So I'll be having only here as secant square theta divided by secant square theta and this is 7 by 2. Okay, d theta 0 to pi by 3. Now this is 1 by 3 still outside, so this is 1 by 3. So integral 0 to pi by 2, I have cos power 5 theta d theta. Now this will be 1 by 3 into into 4 into 2, since n is odd, so 5 into 3, so which results to 8 by 45. So this is the solution for this. Okay, I hope you understood this problem. Let me move on to the next problem here. Okay, let us arrive into some of the results and then try to prove it. Okay, so if I have n as a positive integer, then let us prove that 0 to pi by 2 uh, sine power 2n x dx as the result, which is 0 to pi by 2 cos 2 to the power of n x dx, which is equal to 2n factorial divided by 2 to the power of n into n factorial. Now, what we have noticed here is 2n being an even. Okay, so for both these results, I can put that as 2n minus 1, 2n minus 3, okay, or 2n minus 5 and 1 divided by, I have 2n and 2n minus 2, 2n minus 4, and that is 2 into pi by 2. Further, if I multiply and divide by 2n minus 2, 2n minus 4 into 2, uh, I get 2n. Okay, uh, 2n minus 1 is there, right? I don't have 2n minus 2. What I am supposed to do is multiply and divide by these things. 2n minus 3, 2n minus 4, 2n minus 5, okay, into 1 divided by, again I am multiplying that, so I get 2n, okay, this would be 2n minus 2, okay, 2n minus 4 and 2 and whole square, which I said to multiply and divide by that. So into 2 into pi by 2. So that's that. Okay. So this whole thing I can write as 2n factorial, and denominator is 2n, 2n minus 2 into 2 whole square into, okay, if you remove 2n here outside, so that would lead to that result, which is 2n factorial divided by 2 to the power of n into n factorial whole square into pi by 2. That is the final result. I hope you understood this problem. Okay, so we'll come back again and try to solve more problems on this. If you have any queries, you can. Thank you for listening. Yeah.